All right, investigating monomials. Students will investigate the characteristics of monomials and review, keyword there, review some rules of exponents and apply those rules to simplify monomials. So a lot of the stuff that we're going over today is still a review of your Algebra 1 skills. So a lot of stuff that you'll hear is stuff that you guys should already know, okay? So since we are going to be working with monomials today, it'd be nice to know what the heck is a monomial. So over here, number one, it says monomial. What is it? Here are some examples of monomials. 2, that's an example of a monomial. 5/3, that's an example of a monomial. Every single one of these in these boxes here is a example of a monomial. So what can we say about monomials? It says monomials can be described as, here we go, they can be described as numbers, like that 2, like that 5/3, like that negative 8.5. Not only are they numbers, but they can also be described as variables, like x, that would be considered a monomial. Y, that would be considered a monomial. Any variable. Or it could also be the product of a number and a variable, like 2x up there. That's an example of a monomial put together with both a number and a variable. 9a squared b to the third c to the seventh is another example of a monomial, the product of both numbers and variables. So just remember, monomial is a number, it could be a variable, or it could be the product of a number and a variable. Now right below that it says, however, these are not monomials. So they're giving you some examples of things that are not monomials. So let's take a close look there. Monomials cannot have some certain things here. Here they are. They cannot have variables underneath radicals, like that square root of x there. That's a big no-no. Can't have variables underneath the square root. We also cannot have variables in the denominator, like that 9 over x there. That is not a monomial, and that's because we have a variable in the denominator. It's okay if it's in the numerator, just can't have it in the denominator. And we also can't have any addition or subtraction when we're talking monomials. If there's addition and subtraction, we have a different name for it, and we'll talk about that tomorrow. Right now we're sticking to the monomials. So monomials cannot have variables underneath your radicals, cannot have variables in the denominator, and we can't have any addition or subtraction in those monomials. All right, so now we're going to start looking at some operations with these monomials. But before we do that, we got a couple of vocabulary words that we need to make sure we're familiar with. It says, using these monomials above, identify examples of the following definitions. So here's the first one. A blank is a monomial with no variables. Anybody remember that from Algebra 1? What do we call a monomial with no variables? A number with no letters. Right? Constant. There we go. That is correct. We call that a constant. Anytime we have a number with no variable on it, we call that a constant. So you got a couple of examples of constants up here at the top. We're going to write some of those down. Here they are. 2, that's an example of a constant. 0, that's an example of a constant. All those examples right there, notice all they are numbers with no variables. So there's our first vocabulary word that we need to be familiar with, constant. Number 3 says, in a monomial, the blank is the numerical factor of the variable or variables. So the number in front of the variable. Anybody remember what you call the number in front of the variables? Starts with a C also. Coefficient. There we go. Coefficient. We're awake today. Coefficient. And that's just referring to the numbers in front of the variables. And we had some examples up there. Here's a few of them. 2x, that's the monomial. The coefficient of that monomial would be the 2. It's the number in front of the x. Negative 8.5xy squared, that's a monomial. The coefficient of that monomial would be the negative 8.5. It's the number in front of the variable. 5/3 y squared is a monomial, and the coefficient of that monomial would be the 5/3. Again, it's just a number in front of the variable. So when I ask you what's the coefficient, all I'm asking for is what's the number in front of the variables. So there's our second vocabulary word. We got constant, which is the number with no variables. We got the coefficient, which refers to the number in front of the variables. And we got one more thing here. This one might be a little bit trickier. The blank of a monomial is the sum of the exponents on the variables only. Anybody know what the word I'm looking for here is? Starts with the letter D. Those will be in pre-calc, probably seen this one before. The degree. Degree. The degree of a monomial is the sum of the exponents. I want you to underline that part for me right there. The sum of the exponents. Now, when I say exponents, I'm referring to the variables only. Variables only. So right below that, we got a couple of examples. They give us some monomials, and what we're going to do is we're going to find the degree of each of those monomials. So the first one they've done for us, 2x. The degree of that monomial is 1. And that's because the only exponent is a 1. How about the next example, though? 5/3 y squared. What's the degree of that monomial? 2. It's the exponent. Now the next one a little bit trickier. Negative 8.5 xy squared. I'm looking for the degree. Now notice there are 2 exponents. So we're going to find the sum of those exponents. So what do you get when you add the exponents on the variables? 3. So the degree of this thing is 3. X has a 1 for its exponent. Y has a 2 for its exponent. And when you add that 1 and 2, you get a 3. Same thing right next to it. They give us a monomial. We're going to find the degree of each of these monomials. All right, so if you take a look at that next one, 9a squared, b to the 3rd, c to the 7th. If I add all those exponents together, the degree is 12. There's our degree. All we do is add up the exponents. How about the square root of 5? What's the degree of the square root of 5? 0. There is no exponents. Matter of fact, it's going to be the same thing for the last one. 0. The degree of that would be 0. There are no exponents and no variables. Okay, so that takes care of our vocabulary. Constants, coefficients, and degree. Now let's take a look at some of the rules. Now, as I mentioned, a lot of these rules you should be familiar with already, so we're going to get a quick review over them. Here's our first one, multiply. When we multiply our monomials together. Now, they've gone ahead and expanded each one of these monomials. They took the 5x squared y to the 3rd and rewrote it as 5x times x, which is an x squared, y times y, which is a y cubed. And then they did the same thing with the second monomial. 4x y to the 4th is y times y. Once they've expanded it, they reordered it, put all the x's next to each other, put all the y's next to each other. And now we're ready to simplify. So if I multiply 5 times 4, we get a 20. If I multiply all the x's together, x times x times x, we're going to end up with an x to the what power? 3rd. If I do the same thing with the y's, y times y times y times y times y times y times y, we end up with y to what power? 7. Now, are we really going to sit there and expand each one of our monomials when I give you the assignment? No, you don't have to do that. And that's because we've got a shortcut over here. And this shortcut you guys are already familiar with. 2 things. It says we're going to blank the coefficients and we're going to blank the exponents. Let's start with the coefficients. What were those again? Coefficients? The numbers in front of the variables. So they're talking about the 5 and the 4. What are we going to do with those 2 numbers, the 5 and the 4? Multiply. So right here we're going to put we're going to multiply the coefficients. However, we're not going to multiply the exponents. Well, what are we going to do with the exponents? Add them. We're going to add the exponents. Add up the exponents. So what we end up with is a rule, and that rule is right down here. Anytime we multiply a to the n power times a to the n power, What we're doing is we're doing a to the m plus n power. We're adding up the two exponents, m plus n. Now notice there it does say that the bases have to be the same. In other words, you got to be multiplying an x with another x, a y with another y. Can't mix up the variables. Can't mix up letters. So that takes care of multiplication. Let's take a look at the division now. Over here we've got 18x to the 4th, y to the 3rd, divided by 6x, y squared. They did the same thing. They took each one of the monomials and expanded it. And what we're going to do is we're going to simplify it. So if I take the 18 and divide it by 6, 18 divided by 6 is a 3. Now look what happens with these x's here. This x and this x are going to cancel each other out, which means I'm going to be left with x to what power? 3rd. Same thing's going to happen with some of these y's over here. These y's and these y's cancel, leaving me with a y. So when I simplify this, I end up with 3x cubed y. But again, are we really going to go through all that work and expand this? Of course not. We got a shortcut for this as well. What did we do with the coefficients this time? Divide. What did we do with the exponents this time? Subtract. Subtract the exponents. So then we can make a general rule here, and that rule is going to be a to the n power divided by a to the n power would be a to the m minus n power. Again, take a look at that note. It says that the bases must be the same. So you can divide x's with other x's, y's with other y's, z's with others. But don't mix and match the variables. Got to have the same base. All right, so that takes care of multiplying and dividing. Those are not the only rules. There are several other rules you guys talked about, and these are there. There's 4 more rules that we're going to look at. This one up here at the top says anytime we have a negative exponent, that's a big no-no. So we fix that by rewriting it as 1 over a to the n power. Because we can never, never, never have an answer with a negative exponent. So if you look at this first example here, 5 to the negative 2 power. How do we rewrite that so that we have a positive exponent? 1 over 5 squared. Of course, we can actually square that 5 and end up with 1 over 25. So if we were to put in our calculator 5 to the negative 2 power, the calculator would give us 1 over 25. And that's what we end up with. X to the negative 4 power. Again, can't have a negative exponent, so we rewrite it as 1 over x to the positive 4th power. Never leave your monomials with negative exponents. And this last one over here, actually we're going to have to use one of those rules that we just got through talking about. We're dividing. So what do we say we're going to do with the exponents when we divide? Subtract them. So what do you get when you subtract 3 minus 9? Negative 6. However, if you leave your answer like that, it would be counted wrong. Because you're not allowed to have negative exponents. So what do we do to fix that? You just rewrite it as 1 over b to the 6. It's that simple. All right, so that's that negative exponent rule. Next rule we have is power of powers. We got 2 exponents. We got an exponent inside the parentheses. We got a to the n. But we also have an exponent outside the parentheses. That's this n right here. So the rule says we're going to take those 2 exponents and we're going to multiply them together. So over here, 5 squared to the 3rd power would result in 5 to the 6th power. And of course, we could also put that in our calculator and find out what 5 to the 6th power is. But we'll save that for later. Next one, we got x to the 4th to the 5th power. We multiply those 2 exponents together, we end up with x to the 20th power. All we're doing is multiplying the exponents. And then that last one over there, if I use that same rule, multiply the exponents together, negative 2 times 6. Negative 2 times 6 would be a negative 12. Can I stop there? No. How do you fix it? 1 over b to the 12. Don't ever leave your answer with a negative exponent. All right, so there's the power rule. We'll see that one quite a bit. Next one we have is we have a fraction inside the parentheses and an exponent outside the parentheses. And what this rule says is whenever we have a fraction, we need to make sure we use that exponent with both the numerator and the denominator. So if you look at this example over here, 5 over 8 squared. We need to square both the numerator and the denominator. That's what this rule says. So what do you get when you square 5? 25. What do you get when you square the 8? 64. So 5/8 squared would be 25 over 64. All we're doing is squaring both the numerator and the denominator. Next example, the fraction we have is x over y. And we're taking that to the 7th power. So I need to make sure I use that 7 with both the numerator and the denominator. So that's going to give me x to the 7th divided by y to the 7th. And now I can subtract those exponents, right? No, don't subtract the exponents. Why can't I subtract those exponents? The bases are not the same. That's as far as we can go with that one. Stop right there. Now, the last one's going to require 2 rules. We're going to have to use this previous rule, that power, and we're also going to use this fraction rule. So what I'm going to do is take the numerator, whatever that numerator is, to the 5th power. So I've got b to the 3rd to the 5th power. What am I going to do with those 2 exponents? Multiply. So what do you get when you multiply 3 times 5? 15. So on the numerator, I have b to the 15th power. Now I'm going to do the same thing in the denominator. I've got c squared, and that's going to go to the 5th power as well. So multiply those 2 exponents, and we get a 10. C to the 10th power. No negative exponents this time, so I'm good. I can stop right there. All right, one last rule. One last rule. That's this one right here. I've got 2 variables inside the parentheses, and I've got to the m power. This rule says whatever's in parentheses, I need to make sure I use that exponent with everything that's inside that parenthesis. So if we look at this example right here, I've got 5x squared, and I want to square that. Everything in the parentheses needs to be squared. Starting with the 5. What do you get when you square the 5? 25. But I also need to square the x squared. So it's kind of like this green rule up here that we used earlier. What do we get when you square an x squared? X to the 4th. The rule said multiply the exponents. Next one, I've got xy squared to the 6th power. Everything in parentheses needs to be taken to the 6th power. Starting with the x. That would be x to the 6, y to the what? 12. 2 times 6 is 12. So I end up with x to the 6, y to the 12. The last one over there, we have 4x squared, y to the 4th. That's our monomial. And we're going to take that to the 3rd power. Everything in parentheses needs to be taken to the 3rd power. Starting with this 4 right here. Anybody know what 4 to the 3rd power is? Not 12. 4 to the 3rd power. 64. Remember, when I say 4 to the 3rd power, that means 4 times 4 times 4. X squared to the 3rd power would be x to the 6, with multiplying the exponents. And y to the 4th to the 3rd power would be y to the 12. Again, multiply those exponents. All right, so we end up with 64x to 6, y to the 12. So a lot of different rules there. But again, I'm just reminding you of those rules because you have covered them back in Algebra 1. All right, now let's take a look at some sample problems. Now notice the directions there say we're going to simplify the expressions. After we do that, we're going to identify which simplified expressions are monomials. And if they're not monomials, we're going to explain why they're not considered monomials. All right, so here we go. Number 1, we're going to multiply the 2 monomials together. So here we go. We're going to start by multiplying the coefficients. 2 times negative 4. 2 times negative 4 would be a negative 8. Now I'm going to multiply the a's together. So a times a cubed would be a to the fourth. B squared times b to the third, or b cubed, would be b to the fifth. Now notice only one of these monomials has a c, the other does not. So all we're going to do is keep that c. So after we simplify, we end up with a negative 8, a to the fourth, b to the fifth, c. Do I need to do any more to that? Or am I done with that? I'm done with it. Can I call that thing a monomial? Would that be considered monomial? Sure. Yes, it is. So just put yes. Yes, it is a monomial. Remember, some of these may not be monomials. Number 2, we got 3x squared cubed. Everything in parentheses needs to be cubed. Let's start with the 3. Miranda, what's 3 cubed? 3 to the third power. You can use your calculator, that's all right. I'll take points off for using calculators. 3 cubed.
I'm tired. I don't even remember how to use this.
Well, remember, 3 cubed means 3 times 3 times 3. So at least do that much. 3 times 3 times 3. What is that? 27. Now I need to know what x squared to the third power is. So Miranda, what am I going to do with those two exponents? Add, subtract, and multiply? Nope. These two right here. What am I going to do with those two numbers? 6. And how did you get the 6? Because you multiply. Alright, so we're going to end up with 27x to the 6th power. Can we call that one a monomial? Yes, that is a monomial. Absolutely. Number 3. This time we're dividing. We got x to the 11th, and we're going to divide that by x to the, what is that, 5? Yeah, x to the 5th power. Rule says you subtract the exponents. So what am I going to get when you subtract 11 minus 5? 6. So we get x to the 6th power. Is that a monomial? No? Why not? Yes. Yes, it is. That is a monomial. Now, number 4 over here is a little bit trickier. We're going to have to take this in 2 steps. We're going to ignore this 6x squared y to the third, and we're going to work with this part right here first. Everything in parentheses needs to be cubed. So let me cube everything inside the parentheses. So if I cube the x, I get x cubed. If I cube the y, I get y cubed. If I cube the z, I get z cubed. So everything in the parentheses needed to be cubed first. So that was my first step. Now I'm going to take that and multiply it with the 6x squared y cubed. I'm going to multiply those two together and see what we get. Let's start by multiplying the coefficients. All right, Garrett, what are the coefficients? 6 and 1. So 6 times 1 is a 6. Next thing I'm going to do is multiply the variables, starting with the x's. X squared times x cubed would give us a what? X to the 6th or 5th? We're multiplying. That was one of our first rules. When we multiply, we add the exponents, guys. So when you add those two exponents, you get a 5. Same thing with the y. Y cubed times y cubed. If I add those exponents together, we get y to the 6th. And z cubed, there's nothing to multiply that with, so we'll just keep it z cubed. So this is what we get when we simplify. Question is that a monomial? Yes, that's still a monomial. Still a monomial. Number 5. We got 6a to the negative third power, b squared. And all of that needs to be taken to the negative third power. So, right here, starting with the 6. So I'm going to do 6 to the negative third. Now, we're going to fix that in a minute. But for right now, I'm just going to leave it as 6 to the negative third. I'm going to move on to the 8. I've got a to the negative third to the negative third. The rule says we multiply those two exponents together. So what are you going to get when you multiply negative 3 times a negative 3? Positive 9. Now I'm going to move on to the b. I got b squared to the negative third power. If I multiply those two exponents together, I get negative 6. But I cannot leave it like that. Why? What's wrong with leaving it like that? Can't have negative exponents. So we're going to fix that. Now we're only moving what has a negative exponent, guys. If it doesn't have a negative exponent, you don't need to move it. Like that a to the 9. It's fine. It can stay up in the numerator. We're not going to touch that. The only ones we're going to touch are the ones that have the negative exponents, like this 6 to the negative third power. I'm going to move it down here and make it 6 to the positive 3 power, or 6 cubed. Same thing with that b. I move it down here and I've got b to the positive 6. Now we're not going to leave it like that either. I'm going to go ahead and take care of that 6 cubed. Anybody know what 6 cubed is? 6 times 6 times 6. What was it? 6 times 6 times 6. 216? Is that right? 216. B to the 6 power. Double check that. Yeah, looks right. 216 b to the 6. Alright, so this is what we get after we simplify. Now the next question is that considered to be a monomial? Why not this one? There you go. No, this one is not a monomial, and that's because we have a variable in the denominator. That we cannot have. No variable in the denominator. So we did get it simplified. We just can't consider this to be a monomial. All right, I want you to try that last one there, number 6 for me. Try number 6 and see what you get. Remember, your answer should not have any negative exponents. No negative exponents when you get that. Everything in the parentheses needs to be squared. Also remember, your answer should not contain any negative exponents. All right, let's see how we're doing on number 6 here. We're going to take everything that's in the parentheses and square it. Let's start with that negative 3, that coefficient. Negative 3 squared. All right, so what was that, negative 3 squared? Negative 9, ooh, close, but not quite. Positive 9. Remember, when you multiply a negative times a negative, you get a positive. So it should be a positive 9. X to the, we're multiplying the exponent, so 3 times 2 is going to give us a 6. Same thing on the y there, we're multiplying the exponent, so 6 times 2 is going to give us a 12. So your numerator should start off as 9x to the 6, y to the 12. Everything in the denominator is also going to get squared. So x to the 5th squared would be x to the nth. Y to the negative 2 squared would be y to the negative 4. And z to the, what is it, negative 1 squared should be z to the negative 2. Now hopefully you didn't stop there. And that's because, well, because of 2 reasons. I can still simplify. I can simplify the x's and the y's. And I've also got some negative exponents that I've got to take care of. But I'm going to try and simplify a little bit more here. If we take a look at these x's right here, of course I still got the 9. We have a rule that says when you divide, you subtract the exponents. So I'm going to subtract the exponents. So x to the 6 divided by x to the 10th. If I subtract those exponents, we get x to the what time? Negative 4. Subtracting the exponents. Matter of fact, I'm going to do that same exact thing with my y's right here. So I've got y to the 12th divided by y to the negative 4. I'm subtracting the exponents. So 12 minus a negative 4. What's 12 minus a negative 4? 12 minus a negative 4. 16. 16. Of course, that z, can't do anything with it, so it's going to stay right where it's at. Stay put. Z to the negative 2. Now, we're not going to stop there either, and that's because we still got those negative exponents that we need to fix here. So how are we going to fix this so that there are no negative exponents? What are we going to do? All right, so the 9 is fine. We're not going to touch the 9. That x to the negative 4, though, to fix that, we're going to move it to the bottom. Now it's down here at the bottom. That y to the 16th is fine where it's at. It doesn't have a negative exponent, so we don't need to move it. That z to the negative 2, though, can't leave it there, and that's because it has a negative exponent. So what are we going to do if it's already at the bottom? We're going to move it up to the top. So now it's going to be up here, z, and now we've got a positive exponent, positive 2. So we should end up with 9 y to the 16th z squared all over x to the 4. Now, if you've got your variables in a different order, you've got 9z squared and then y to the 16th, that is still okay. As long as you've got the exponents right, you're okay. So here's what we end up with. So the next question is that considered to be a monomial? No. Why not? Again, same reason. We have a variable down there in the denominator. Can't have that. So number 5 and number 6 are not monomials, and that's because there's a variable in the denominator. Okay, we got 2 more we're going to look at. This is more of the application. These are more the type of questions you might see on a test. So if we look at number 7 here, it says that the rectangle has a width of 3x squared y to the 6th and a length of 8x to the 5th y to the 3rd. And we're looking for an expression that would represent the area of this rectangle. Area. Anybody remember the formula for area of a rectangle? Length times width. So find the area of a rectangle, we multiply the length times the width. So that's what we're going to do. We're going to multiply the length, which is 8x to the 5th, y cubed. And we're going to multiply that with the width, which in our case is going to be the 3x squared, y to the 5th. That's what we're multiplying together. So let's see what we get here. Let's start by multiplying the coefficients. Coefficients, 8 times 3. 8 times 3 is 24. X to the 5th times x squared is x to the 7th. Remember, we're adding exponents. And y to the 3rd, or y cubed times y to the 5th, would be y to the... Did I write it down? Oh, should that be a 6? So this 3 right here should be a 6. All right, so what do we get when we add those together? Oh, the 5 should be a 6. And this one was a 3. All right, so when we add those together, we get a 9. Y to the 9th top. So this right here would represent our area. And we found that by multiplying the length and the width. All right, one last one here. Now this one right here, we got a triangle. They gave us the area of that triangle. It says it's 14, x to the 4th, y to the 9th. What they want us to do is find an expression that would represent the base of the triangle. Well, anybody know the formula for the area of a triangle? 1/2 base times height. That is correct. So, let's see here. We know the area. We know it's 14 x, what is that, 4? Y to the 9 equals, now we don't know the base. That's what we're looking for. But we do know the height. It's 7x squared y to the 5th. So what I want to know is, what is b? What is the base? That's what we're solving. So anybody got a suggestion? What can we do to start off? How about we take care of this 1/2 first? Let's do this. I'm going to take both sides of the equation, and I'm going to multiply it by 2. And where we can get rid of that stuff there. So if I multiply 2 times this, what am I going to get? What's that? I heard it. 2 times 14x to the 4th y to the 9th. 28 x to the 4th y to the 9th. That's going to equal b times 7x squared y to the 5th. Remember, the idea here is we're solving for b. What is b? So what am I going to do next time? Divide by here's what we're dividing by. That way we can get rid of this, leaving us with b by itself. So let's use our rules. 28 divided by 7 would be a 4. X to the 4th divided by x squared would give us a x squared. And y to the 9th divided by y to the 5th would be y to the 4th power. So our base would be represented with this expression right here, 4x squared y to the 4th power. So it's just like solving an equation. This time we're working with monomials.